Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I've log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3, because again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I've log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2, and I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.